Hey people, so we are looking at quads in geometry. You can go through term 2, topic 3, that document on Euclidean geometry, pages 29 till 44. And then the interior angles of a quad add up to 360, something you've probably learnt already in grade 7. Then you must know all the properties of the following quadrilaterals. You can refer to the previous lessons that we've done on that. So the trapezium, parallelogram, rectangles, rhombus, square, and kites. And then anything that we've learned in geometry so far would be helpful to you to solve certain side lengths or angles that we have to find in the problem solving. So looking at example 1, it's a quite straightforward one where they're looking for x, y, and z. X is an angle over here, and that angle, of course, we can find by using the fact that they tell us this is a parallelogram. It's a bit of information given because then we know all the properties of a parallelogram apply. So let's fill in what we need on here. It would help us a lot if we knew that the sides opposite one another are parallel to one another and equal. So those things could possibly help us solve things. Okay, and then that's all I'm going to fill in that's really going to help us. Now, so that's seeing that these sides are parallel to one another, I, with the diagonals, am able to form a pair of alternate angles where x and 60 degrees will be the same size. And then for y, I can just work in this triangle. And I then know y plus 60 plus 36 is 180 degrees. And then in a parallelogram, since we know opposite sides are equal, we therefore also know z is equal to 40 millimeters. But how to set this out is the big question. So the first thing I can go about is saying, yes, x is equal to 60 degrees because AD is parallel to CB, and they form a pair of alternate angles. Okay, I've solved x. Now for y, I can go ahead and say y plus 60 degrees plus 36 degrees is equal to 180 degrees. And I'm going to call that triangle AOB. Let me just insert something here. This is O. Okay, at the center where the two diagonals meet. And those are the interior angles of triangle AOB. That's not an A. Let's make it an A. AOB. So 60 and 36 gives you 96. And if you so y plus 96 gives you 180 degrees in other words, and then if we subtract 96 from both sides, the value of y is equal to 84 degrees in size. And then z, it's straightforward. You can just say z is equal to 40 millimeters because it is opposite sides of the parallelogram. Okay, and we abbreviate parallelogram as such. Now on to the kite. In the kite, calculate with reasons the size of angle B, and then we know that B is equal to C, being the opposite angles in a kite which are equal. So we can go ahead and then just state that angle B is equal to angle D, sorry, not D, C. Let's just fix that, C, because they are the opposite angles of your kites, which are equal. And so we know A plus B plus C plus D gives you 360 degrees, seeing that it's in a quadrilateral. So 90 degrees plus B, and I'm going to name C B as well because they're equal, so I can replace the one with the other, plus another B angle That's the angle over here. The C I replaced with B, plus 40 degrees, all adds up to 360 degrees, because they are the interior angles of a quad. Okay, and then 90 and 40 gives you, if you add like terms, 130 degrees. And then I've got like terms in the sense of two of the same kinds of angles, 2 of angle B's size plus 130 degrees is equal to 360 degrees. And this, to isolate B, the process starts, subtract 130 from each side, and then 2B, or 2 of angle B, is equal to 230 degrees, divided by 2, and the size of one angle B is equal to 115 degrees in size. And now for question 3, ABCD is a parallelogram, and they want you to determine with reasons the sizes. So 3.1 of angle B1 firstly. So let's just get this here. So here's angle B1, and we can clearly see B1 is inside the triangle AEB, and which is quite useful is that they've told us AE is the same length as AB in this triangle, so therefore we also know B1 is equal to 55 degrees. So therefore we firstly say AB is equal to AE, and that is given, and therefore angle B1 is equal to angle E, which is 55 degrees. Okay, so the reason here would be angles opposite equal sides in triangle, and I've got to be specific which triangles. AEB. Why I've got to be specific is because there's more than one triangle in this specific diagram. So we've got B1, then B2, question 3.2 asks of you to find the size of angle A. So angle A is the only angle missing in this triangle AEB then, so we can carry on in that triangle and say angle A plus the two 55-degree angles in the triangle should add up to 180 degrees. So the reason, interior angles of triangle, once again, let's be specific, AEB. And now adding the like terms 55 and 55 gives you 110 degrees. And then if we subtract it from each side, the angle A's size remains to be 70 degrees. Okay, we've got B1 and A. So let's just write here. I kind of forgot. This is 3.1 that we're answering here. This is 3.2. Now for 3.3, it helps if we could write it like that. Then for 3.3, angle C is what they require of you to solve. But that is just in the parallelogram, an opposite angle to angle A, which we have just solved. So that's nice. We know they're equal. So angle C, I'm saying, is equal to angle A. So it's 70 degrees in size as well. And our reason is opposite angles of palm. And I'm going to be specific. That's Pam, not palm. Palm. And then this is ABCD, of course. Okay, so 3.3 done, 3.4. B2 is what they require of you to solve, and B2 is over here. And so, seeing that these sides opposite one another in the parallelogram are parallel, we know that AE can make a pair of alternate angles with BF in that manner, and it forms the angles at 55 degrees and B2, which are then equal. So we can say B2 is equal to, we can say 55 degrees straight out, and then that it is alternate angles between the parallel lines AE and BF. Shortening that helps us to locate the actual angle. And then 3.5, they ask of you to solve D1. D1 is over here, and D1 together with the 35-degree angle is an angle opposite B over here, which we know the size of B1 and B2. So if we add these two angles together, it gives us the size of D1 and 35. So let's write a statement for that first so you can make sense of it and then substitute. B1 plus B2 together should be the same size as D1 plus the given 35-degree angle. And the reason is opposite angles of palm ABCD. So now we substitute what's been given and what we have solved. B1 and B2, B1 and B2 each is 55 degrees. So 55 plus 55 is equal to D1, which we need to solve, plus 35 degrees. So some of you would prefer this step to immediately add these two together as 110, but I'm only going to do it for the other people in the next step. So 110 degrees is equal to D1 plus 135 degrees. And then we isolate D1 by subtracting 35 from each side of the equation. And so your angle D1 has the size of 75 degrees. Right, and that's it for question 3. And then your homework or practice work, let's call it that. Question paper C2, you can do question 2.1. Question paper E2, you can do question 2.5. Question paper F2, you can do question 3.2. And question paper H2, you can do question 2.1 till 2.3.2. So all of this, and that's it. Have a lovely day, guys.